Hello everyone, welcome back again. So in this segment we are going to talk about subset. So given two set A and B, we say that one set A is subset of another set B, and we denote them as using this symbol. Okay, using this symbol if every element of A is also an element of B. So here you can see some diagrammatic thing here. B is the set. Okay, B is a set. B is containing some elements and A is inside B. Okay, so that means every element of A is also an element of B. So let's see an example. Say B is a set of some even numbers where the numbers are from 2 to 16. Okay, 2 4 6 8 10 12 4 14 16. Now A is another set where we have 4 8 12 16. Now if we look at these two sets, every elements of A is also in elements of B. Okay, so here if we draw the diagram like that, so B has all the numbers 2 4, let's say 4 8 12 16. Okay, and we have also here 2 6 8 10 12 is also already there. All right, 14. So 1 2 3 4 5 6 7 9. So I have listed it two times. Okay, so now we can see that this is our A. Okay, A has 4 8 12 and 16. All right, so here every elements of A is already in every element of A is an also element of B. So you can say that A is a subset of B. Okay, and we use this symbol subset as a subset. Now what about B is a subset of A or not? So every element of B is not in element of A. So there are few numbers like 2 6 10 and 14, they are not member of A. All right, so that means B is not subset of A. Okay, so now each set is subset of A. Each set is the subset of the same set. Okay, every set is subset of the same set because every element of that set is an element of that set. Okay, the empty set also subset of any set, for any set, because the empty set has no elements. All right, so for any set, empty set is always the subset of that set. For example, if A is the set of prime numbers and B is the set of all odd numbers, so what do you think, whether A is subset of B or not? A is the set of all prime numbers, okay, and B is the set of all odd numbers. Now if we think about A is the set of all prime numbers, so there is only one prime number which is even, which is 2. Okay, one is prime number, so there is another prime number which is even 2. Okay, so we can say that in the prime number we have at one even number, okay, which is 2. So this member is not the elements of A, or is not the elements of B. Okay, so we can say that A is not subset of B. So this is the fact, is that if A is subset of B, then we can say that the number of members in A is going to be less than or equal to the number of elements in B. All right, so if A is subset of B, okay, so that means all the elements of A is also elements of B, but B can have actually more members. Okay, B can have more members, but all the elements A has to be in the B. So B can have more members, so the number of elements in A has to be less than or equal to the number of elements in B. The proper subset. The proper subset means given two set A and B, we say that A is a proper subset of B, and in that case we use this symbol, only this symbol. Okay, so this one stands for subset and this one stands for proper subset. All right, if every element of A is an element of B, but there is at least one element in B that is not contained in A. Okay, so every element of A is an element of B, but the member in B, there has to be at least one element extra. Additionally, there has to be one element which is not in A. All right, so if A is proper subset of B, that means the number of elements in A has to be less than number of elements in B. Okay, now for example, A is 1, 3 and 5 and B is 1, 3 and 5. So in this example, every element of A is in every element of B. Okay, so we can say that A is subset of B. But to be a proper subset, there has to be at least one element in B which is not in A. Okay, so we can say that A is not actually proper subset of B. Okay, but another example, let's see, A equals to 1, 3, 5 and B equals to 1, 3, 5 and 7. All right, so in this example, A is subset of B. Now to check whether A is proper subset of B, we can see that there is at least one element 7 which is not in the A. Okay, so that means A is proper subset of B. So if this is a proper subset, then the number of elements in A will be less than the number of element in B. B has at least one items. Okay, it can be more than one items, but B has at least one item that is not in the A. Okay, now another definition is that we are going to check whether two sets are equal or not. So given two sets A and B, we say that A equals to B. That means two sets are same if A is a subset of B and B is a subset of A. Okay, now if A is a subset of B and B is a subset of A, then they both becomes same set. So without definition, we can say that if there is two set A and B, okay, if both set contains the same elements, okay, then they are actually same set. For example, A equals to 137, say A equals to 135, B equals to 135. Okay, so they are same set. So A equals to B, so they both of the set has same elements. Okay, now as a formal definition, given two sets, we can say that two sets are same if A is a subset of B and B is a subset of A. Okay, so here you can see that every element of A is in element of B, so that means A is a subset of B. Now for B, you can see that every element of B is also in element of A, so that means B is a subset of A. Okay, now if this both condition is true, then we can say that A and B, they are same set. Okay, And now if A equals to B, the size will be same. Okay. Now how we can prove that two sets are equal? If A and B are sets and A equals to B, we can say that A and B will be the same set, or A will be equal to the B if A is a subset of B and B is a subset of A. Now what we can do, we can use some mathematical statement to prove that. Okay. So here you can see that we are using if, actually stands for if and only if. Okay, so this symbol, if we write if I double f, that means if and only if. Okay, so what we can do, like we can prove it like that. We are going to assume that A equals to B. Okay, we can assume that A equals to B, then it will follow directly that both A is subset of B and B is subset of A, and will be done. Okay, we are going to assume that A equals to B. Then if we can prove that after A equals to B, if we can prove that A is a subset of B and B is a subset of A, that means we are done. Okay, our proof is done. All right. Now let's assume that A is subset of B and B is subset of A. So after that, if we can prove that A is same as B, all right. So in that case, we have to prove that A is same as B, A equals to B. Okay. Now how we can prove that? Let's first assume that different condition. So the first condition is the base case. We can say that if the best case, in the best case we can assume that A is an empty set and B is an empty set. Okay, so we will start with that A is an empty set and B is an empty set. Okay, so if A is empty and we know that B is a subset of A, that means B is also empty. Okay, A is empty set and B is subset of A. Okay, that means all elements of B is also element of A, but A is empty, that means B has to be empty. Now A is empty and B is empty, that means they are same. Okay, we can do the vice versa for starting with B. So similarly we can assume B is empty and A is subset of B. Okay, that means A has to be also empty set, so we can prove that A equals to B. So if A and B are empty set, and if this condition is true, A is subset of B and B is subset of A, then A is equals to B. Okay, now let's assume for any other elements. Okay, so let's A is a set where A has couple of elements. All right, so let's arbitrarily choose any elements X which is a member of A. All right, now as A is subset of B, all right, and X is a member of A, that means X is also member of B. Okay, any elements of A and A is subset of B, that means the same element is also member of B. Okay, all right, now we are supposing that that means B has an element where we have X. Okay, now as B is subset of A, okay, as B is subset of A, all right, then X is also member of A. Okay, B is subset of A, that means the same member is also member of A, and that will be true actually for every member of A and B. Okay, so for every member, every element of A, okay, as A belongs to A is subset of B and B is subset of A, that means for every member of A and B, they are going to be content in both of the set. Okay, and all together we can say that the elements of A and B are going to be exactly same, so they will be same. All right.